Let's walk through Transport Layer Security, or TLS, which is one of the most important security protocols you'll need to recognize for the Security Plus exam. TLS is responsible for encrypting data while it travels across networks. The exam often refers to this as protecting data in transit. The key is understanding that TLS provides secure communication between systems by encrypting traffic and protecting confidentiality. We'll begin with the core purpose of TLS. If a scenario describes encrypted web communication, secure online transactions, protected login sessions, or encrypted data traveling across a network, you are dealing with TLS. Transport Layer Security creates a secure encrypted tunnel between systems, so attackers cannot easily intercept or read the transmitted information. For example, when a user logs into an online banking website and sees https:// along with a padlock icon in the browser, TLS is being used to encrypt the communication between the browser and the web server. A common exam trap is confusing TLS with TCP or UDP. TCP and UDP transport data, while TLS encrypts the communication itself. Now let's go deeper, because this is where exam questions become more scenario-based. If the question mentions HTTPS, secure email, encrypted APIs, VPN tunnels, or protected authentication sessions, TLS is often operating behind the scenes. For example, when an employee remotely accesses a company web portal using HTTPS, TLS encrypts the login credentials so they cannot be easily captured during transmission. Now let's address an extremely common Security Plus exam topic. If a scenario mentions Secure Sockets Layer, or SSL, you should recognize that SSL is outdated and deprecated. Modern secure communications use TLS instead. Although many people still casually say SSL certificates, the actual protocol in use today is usually TLS. This is a very common test point, because the exam may intentionally reference SSL to see if you recognize that TLS replaced it. Now let's connect TLS to certificates and authentication. TLS commonly works together with digital certificates issued by certificate authorities, or CAs. These certificates help systems verify identity before encrypted communication begins. For example, when a browser trusts a secure website certificate, TLS can establish an encrypted connection while also helping confirm the legitimacy of the server. Now let's talk about the relationship between TLS and ports, because this helps connect multiple Security Plus concepts together. HTTPS commonly uses TCP port 443. TLS encryption. This means TCP handles reliable transport. TLS handles encryption. HTTPS provides the application service. The exam frequently combines these concepts into layered networking questions. Now let's bring everything together using recognition patterns. If the question describes encrypted communication over the internet, think TLS. If it involves protecting data in transit, think TLS. If it mentions HTTPS or secure browser communication, think TLS. If it references SSL replacement or modern secure encryption protocols, think TLS. If digital certificates and secure sessions are involved, TLS is likely operating in the background. The most important takeaway is to separate transport from encryption. TCP and UDP move data. TLS protects the data while it moves. TCP focuses on reliability. UDP focuses on speed. TLS focuses on confidentiality and secure communication. If you can recognize those distinctions and understand how TLS works together with HTTPS, certificates, and encrypted sessions, you'll be able to quickly eliminate incorrect answers and confidently select the correct protocol on the exam.